Hello my dear students, welcome to IMS Academy. So in this particular session we are going to discuss regarding the foundation course of network theory subject, the last session regarding basic laws. This is the fourth part. Okay, so this is a session common for three branches: EC, electrical and instrumentation, right? So all of you kindly like and share this video link with all of your friends so that they also will get benefited from this particular session, right? Whoever visiting very first time for our YouTube channel regarding, okay, so all of you kindly subscribe our YouTube channel, IMS Gate Academy YouTube channel, and then click on this link, whatever currently live session is happening. All of you like this live session and share this link with all of your friends. Okay, and whoever missed the earlier lectures regarding network theory foundation course, no issue at all. So all of you can in your free time just check the playlist in our YouTube channel. Okay, regarding the network theory subject foundation course, we have done 9 sessions earlier. So this is the 10th session regarding the network theory subject, right? So in your free time, kindly watch those sessions if you have missed any of those. Okay, so before going to start today's session, I am going to give 2 important updates. After that, we are going to proceed in this particular session, right? Okay, so the first important update is regarding our Telegram channel. Okay, so regarding this particular link already provided in the description of this particular video, whoever not yet joined till now, you people can kindly join our Telegram channel. Yeah, good evening Mathan. Right. So say for example, whenever in future whatever upcoming YouTube live sessions are there, so all those updates you are getting the updates here, and whatever faculties are discussing or writing on this digital board during the class, that particular notes will be sharing in the PDF form, okay, in this particular Telegram channel. Okay, and in addition to that, whenever you will be getting all the important updates whenever we are conducting seminar or webinar, and even you are getting all the important updates regarding government job notifications as well. Okay, in addition to that, on daily basis our faculties will provide one quiz question, so all you people can actively participate and you can check your confidence, okay, regarding that particular question or concept, etc. The very next day our faculty will provide the solution for that quiz question. In that way you are getting one opportunity, you are learning one question on daily basis. Okay, right. So it is free for everyone. Okay, so all of you kindly join, whoever not yet joined till now. Okay, and the next important update is, so regarding our live online program which we are offering at our IMS Gate Academy for the aspirants who are targeting for GATE 25 or 26, right? So here all these are the program features of GATE live online program, right? Whoever enrolling for live online program, all the students are getting the access of 800 plus hours of live online classes. So here during our live online classes, every faculty, okay, will be discussing the whatever the concepts are there. Okay, our faculties will present from very basics to the application level, and even like for every concept based on the possibility, our faculties will cover all the variety of questions, practice questions and gate questions as well, so that you are getting the good command over the concept and good command over how to solve the questions. Okay, right. In addition to that, we are providing for every subject, we are providing the theory book and then we are providing the exercise book. Okay, so all the exercise books with respect to your branch, okay, together you are having 4,000 plus practice questions. If you are able to practice this many questions, you will be definitely, getting good command over the concepts whatever you have studied in our live classes. Okay, and you are getting very good command how to solve the gate questions as well. After that, we are providing 34 plus years gate question bank, right? This is one of the very special book which we are offering at our IMS Gate Academy for all the enrolled students, right? So here, based on the possibility, wherever required, we have provided more than one solution, and even for typical questions, our faculties have provided the video solution as well, right? So in the solution section, you can observe the QR code. So just you have to open the QR scanner in your mobile, and then if you are scanning the corresponding QR code, then the respective video solution will be played. So in that way, you are getting great opportunity while you are solving the gate question bank. Okay, right. And in addition to that, here at our IMS Gate Academy, we are providing 130 plus online tests, which consist of various chapter tests, subject test, and then in the subject test also we are having basic test, advanced test, and then multi-subject test as well. After that, we are having all the mock tests. So all together we are having 130 plus online tests. whoever attend in the classes and then practice in the exercise book questions and then gate questions, after that whoever attempting these tests, definitely they can get very good rank in the upcoming years, right? So, and in addition to that, we are providing 12 My Plan sessions as well. So for all the enrolled students, we are providing 12 My Plan sessions. So on an average, every month, each and every student, they can book one My Plan session with the corresponding mentor, and they can get the proper guidance and study plan. And even if they are facing any challenges regarding their gate preparation, they can discuss with the corresponding mentor so that they can get the better strategies in order to reach their goal in a smooth manner, right? So here at our IMS Gate Academy, we are providing each and every resource that is required for all the gate aspirants who are targeting to get very good rank in the upcoming years, right? So now it's up to you. Now it's the time for you. Okay, whoever interested, whoever want to get very good rank in the upcoming years, so you people can contact to any of these two numbers. Okay, you can get the complete details of regarding live online program. Whatever the doubts you might be having regarding our live online program, you can discuss with our counselors. They will clarify all your doubts. Okay, after that you can enroll for our live online program. You are getting the maximum benefit. Okay, right. So all of you kindly share this valuable information to your friends and juniors, whoever targeting for gate 25 or 26. Okay, right. So I hope all of you are eagerly waiting for the session. So let us start now, right? So in the last class, we have discussed regarding KVL and we have discussed a few gate questions in the last class, right? So in this particular session, we are going to discuss so many gate questions I am going to cover in this particular session. So initially, let us continue based on KVL, and then since earlier sessions we have covered regarding KCL also. So with the help of KCL and with the help of KVL, all the possible combinations, right? Whatever the variety of gate questions are there, that I am going to cover in this particular session, so that all of you are getting good command over KCL and KVL. Okay, how easily we can apply either KCL or KVL with the help of these basic laws, how to solve the given gate question, right? So whatever the variety of models are there from EC branch and electrical branch together, I am going to discuss variety of questions. All of you will get the good command over these two basic laws, KCL and KVL. And at the last, I am going to cover even with respect to active elements, that is voltage sources and current sources. With respect to that, even equivalent circuits, one small topic is there that I am going to cover at the end of this particular session, right? So I hope it is clear for everyone regarding the agenda of this session, right? So now let us start. This is the question which is asked in gate EE in the year 1997 for 2 marks, right? So all of you give a try. So for every question, I will give some time for you to try. Okay, whatever the basic knowledge you are having from your BTech regarding network theory subject. So with the help of that, all of you give a try. And if you are having MCQ question, okay, then you can choose among the given choices whichever option is correct. If it is NIT question, then you can mention after solving the question, whatever the answer you are getting, you can mention in the chart. Okay, no, don't hesitate whether your answer is correct or wrong. Okay, because you are practicing, right? You are learning the subject. So whatever the answer you are getting, you can mention in the chart. If it is correct, then I will appreciate. If it is not correct, no problem. While I am discussing the solution, while I am discussing the explanation for the given circuit, from there you can try to understand and where you had done the mistake, cross check. Okay, in that way you are getting great opportunity to learn the subject in deeper. Okay, once if your basics are strong, of especially regarding network theory subject, then definitely you can easily perform regarding analog circuit subject easily, right? So all of you give a try. in this question you are supposed to calculate the voltage source value and the current flowing through this 1 ohm resistor. Both the values you have to calculate. E and I you have to calculate. Yeah, time up. So whatever the answer you are getting, at least if you have calculated among these two parameters, at least one parameter if you have got the answer, at least you can mention in the chart. Okay, right. So for this question we have to calculate the value of E and the value of I. Here value of E is nothing but this voltage source value, and the current value is nothing but the current flowing through this 1 ohm resistor. Okay, right. So here just observe the circuit. Okay, whenever you are having network theory questions, okay, so especially when you are having the circuit, just after reading the question, just observe the circuit carefully, so that what will happen, whatever the given data is there, okay, whatever the given data is there, you are getting the, just by observing the data, observing the circuit diagram, you are getting the clue from where we can start. Somehow that if you are getting the clue from where we can start, from that point if you are starting, then definitely you can get the answer quickly. Okay, so if you are practicing good number of questions, then definitely you will be getting the command from where we can start. Okay, so just observe here, in this question we have to calculate E and I. Okay, now just observe the rest of the circuit, whatever the components we are having, all are resistors, right? So here except this resistor, regarding all other resistors you are having simply resistance value mentioned. Here we are supposed to calculate the current, but here for this 4 ohm resistor if you observe, you are having the resistor value and you know the current flowing through this particular resistor. That means now you can start from here. Okay, so here 4 ohm resistor is there and the current 2 ampere is flowing in this particular 4 ohm resistor. By using Ohm's law, we can calculate the voltage. 4 into 2, that is nothing but 8 volts. 8 volts, right? Now if you carefully observe, this 4 ohm resistor and 1 ohm resistor, both are connected in, how they are connected? They are connected in parallel, right? So in parallel, obviously voltage will be same. In parallel, voltage will be same. Now you know the voltage, you know the resistor. By using Ohm's law, we can calculate the current. All of you give a try. How much current is flowing in this 1 ohm resistor? In this 1 ohm resistor, voltage is 8, resistance is 1 ohm. Okay, current is nothing but voltage by resistor. So 8 by 1, that means 8 ampere. See, earlier case you know the current, you know the resistor value. By using Ohm's law, we got the voltage. Here you know the voltage, you know the resistor. By using Ohm's law, we got the current. Okay, right. Now up to here we somehow there we got the values. Okay, here this value already given. This value we calculated. Okay, how much current is flowing in this 1 ohm resistor. Now at this particular node we can apply KCL. Okay, so just observe, for this particular node total 3 branches are connected. Okay, in these 2 branches together, 10 ampere current is leaving. That means here in this particular branch 10 ampere current should enter. If 10 ampere enters here, then together 10 ampere can leave. Okay, now whatever this 10 ampere is there, I am representing once again just for reference like this. Okay, from this node to this node, in this 1 ohm resistor, the current is flowing like this, 10 ampere. Now by here, since current is flowing like this, the voltage polarities you will be getting plus and minus, right? You can use Ohm's law here, 10 into 1, that means you are getting 10 volts. 10 volts you are getting, right? Okay, now up to here if you observe, we are calculating based on the given data. Okay, if current is given, then accordingly we are calculating the voltage. Okay, and after that with the help of voltage we are calculating the current. Like that we are doing the process by using basic law, that is Ohm's law, and then KCL, whatever we have discussed earlier, right? With the help of, because now this is the last session regarding basic laws. That's why whatever the laws that we have studied earlier, even you are getting the opportunity to revise, to apply those laws also once again, right? Okay, or we can say it is a recap of earlier concepts also, right? Now you can observe, here you are having 6 ohm resistor, 6 ohm resistor. All of you give a try, how much voltage you are having across the 6 ohm resistor? How much voltage we are having across 6 ohm resistor? All of you give a try. See, just carefully observe. Here I want to know the voltage across 6 ohm resistor. Okay, that is same as the node voltage, that is same as that is same as the voltage across these two terminals. Yes or no? The voltage across these two terminals I want to calculate, right? Now if you observe on the right hand side, here you are having 8 volts. Here we are having 8 volts. I am keeping as it is polarities, voltage polarities. Now whatever 10 volts here you are having, just keep this voltage polarity here vertically. Just keep this resistor, whatever horizontally is there, just make vertical alignment. Then you are getting the voltage polarities like this, plus minus 10 volt, plus minus 10 volt. You can observe here, for this resistor, the ending terminal is minus, and for this resistor, starting terminal is plus. You can observe minus plus. Yes, I have kept as it is. Now, overall if you observe between these 2 points, here you are having resistor, on the other side you are having 2 voltages, right? So those 2 voltages I have kept in the vertical alignment like this. Now here if you observe, voltage polarity is plus minus. That means we can add. So that means we are getting plus minus 18 volts. If voltage polarities are opposite, then we will be subtracting. Because you are having same polarities, you can add. Okay. So that means now we got the voltage across 6 ohm resistor is nothing but 18 volts. Okay. Voltage across 6 ohm resistor is nothing but 18 volts. Now once again you can use Ohm's law. You know the voltage, you know the resistor, right? 18 by 6 is nothing but 3 ampere. I hope it is clear for everyone. If you are having any doubt, you can mention the chart. Okay, I will repeat. So in this way, most of the network theory questions in the GATE exam you can solve easily if you are having very good command over the basic laws. Okay, right. Fine. So now just observe, just like here at this particular node I have applied KCL. In the similar way, now you can apply KCL at this particular node. Here in this branch 3 ampere current is leaving, in this branch 10 ampere current is leaving, together 13 ampere current is leaving. That means here in this branch 13 ampere current should come. If 13 ampere current comes here, then together 13 ampere current can leave. Okay, so here in this 1 ohm resistor, the current direction I is mentioned in the same direction, and here just now we got 13 ampere, so that means I equal to 13 ampere. Whatever this current, same thing we can represent here also, 13 ampere. So as of now we got I equal to 13 ampere. I equal to 13 ampere, right? Okay. Now once again you can use Ohm's law. 13 ampere, 1 ohm resistor, that means 13 volts you are getting. Now once again you can apply KVL, or otherwise you can follow the same pattern. Okay. Here we have to calculate voltage across this particular source, that is nothing but across these 2 terminals, right? So on the other side, just consider, just now here we got 18 volts. Just now here we got 18 volt, I have kept as it is, right? Now whatever this 1 ohm resistor is there, keep vertical alignment. So here once again you are getting the voltage polarity is same, here 13 volts, right? So the polarities are same, plus minus. Now we can add the voltages, right? 18 plus 13 is nothing but 31 volts. That means here voltage value of this particular source we are getting 31 volts. Okay, I hope it is clear for everyone. So for this question they asked you to calculate 2 parameters. One is voltage across this particular voltage source and current flowing through this 1 ohm resistor, right? Voltage across this particular source is 31 volts and current flowing through 1 ohm resistor is 13 ampere, right? I hope it is clear for everyone. Okay, right. Next question, This question is also asked in the GATE EE in the year 2008 for 2 marks. All of you give it a try. You will be getting like this kind of circuits, okay, in your analog circuit subject or EDC when you are drawing the equivalent circuits with respect to BJT or MOSFET. Okay, so there you will be having emitter, base, collector, etc. Okay, so based on the given terminology, you can decide whether the question belongs to network theory or whether the question belongs to analog circuit. Okay, all of you give it a try. This is a very interesting question. All of you give it a try. Whatever the answer you are getting, you can mention in the chart. Yeah, time up. Okay, what is the answer you are getting, you can mention the chart. Okay, so in this particular question, you are having the circuit diagram like this, and here in this question, you have to calculate the current I. Here you are having current I, so this current value we have to calculate, right? So just observe here, in this question, you are having voltage source here, but it is dependent voltage source. Okay, so this dependent voltage source output value is 4 times VAB, where VAB is nothing but the voltage across these two terminals. Okay, right. And here in this particular circuit, okay, the current I is flowing, right? Current I is flowing. So by using Ohm's law, you are getting voltage across 3 ohm resistor is 3I. Similarly here, the same current is flowing because here terminals are open, there is no current flowing here, right? The same current is flowing like this. So here once again by using Ohm's law, current into resistor, that is voltage. I into 1 ohm, that is I. Okay, the voltage across 1 ohm is I. Now just apply KVL around this particular closed path. Okay, if you apply KVL around this closed path, what you are going to get? Minus 2 plus, minus 2 plus 4 times VAB, then plus 2 minus 3I. Similarly, plus 2 minus, you can consider minus I is equal to 0. While you are considering any closed path, while you are writing the KVL, for every element you can consider the starting polarity or you can consider the second polarity, no problem. Okay, so for the timing I have considered the second polarity for every element voltage. Okay, now here from here what you are going to get, 4 VAB minus 4I is equal to 0. So here 4 will get cancelled, from here you are getting VAB equal to I. Okay, what is VAB? VAB is nothing but voltage across these two terminals, A and B, right? So you can represent VAB is nothing but VA minus VB. VAB is nothing but VA minus VB. On the right hand side you are having I. Right hand side you are having I. Okay. Now just observe. Here somehow there if you are able to calculate VA and VB. Okay. After that if you substitute, from there we can calculate the current I. That's all. Okay. So here first let us calculate regarding VA. VA is nothing but what? VA is nothing but the voltage across these two terminals, right? So here across these two terminals you are having 1 ohm resistor, and here there is no current flowing. That means 5 volt source, 1 ohm, 1 ohm, all these three elements are connected in series. In series current will be same, voltage will get divided. Okay. In this circuit you are having 1 ohm, 1 ohm, both are having the same resistors, right? Same resistance value you are having. Whatever supply voltage you are having, that entire supply voltage, half portion you are getting here, other half you will be getting here, right? So directly you can write VA equal to 5 by 2. VA equal to 5 by 2. Okay. Here you are getting 5 by 2, here you are getting 5 by 2. Similarly here VB is nothing but the voltage across these two terminals. Okay. So here across these two terminals you are having 1 ohm resistor. So by using Ohm's law we already got the voltage as I, right? So that one you can represent here. VB is nothing but I. On the right hand side you are already having I. Okay. Now you can bring minus side to the right hand side, it will become positive. I plus I is 2I. 2I is equal to 5 by 2 we can write as 2.5. Now you can bring 2 to the right hand side. From there you are going to get I equal to 2.5 divided by 2, that is nothing but 1.25 units are ampere. I equal to 1.25 ampere. So you can observe you are having in option B. In option B you are having 1.25 ampere. So option B is the correct answer. Okay, I hope it is clear for everyone. Okay, you will be getting like this interesting questions in your analog circuit subject when you are drawing the BJT or MOSFET equivalent circuits. Okay, you are having one terminal will be common with respect to your input and output. Okay, so you will be having one of the terminal is input, other terminal will be output. Okay, like this equivalent circuits there you are going to get. Okay. Next question, this is a very interesting question. I hope all of you can get the correct answer. Okay, all of you give a try. In this question we have to calculate Vs and then we have to calculate the current flowing through this particular 10 volt source, that is Is. Here in the given circuit two unknowns are there. One is Is, okay, another one is Vs. These two we have to calculate. Here in all the four choices the first parameter or first value is correspond to current, second value is correspond to voltage. All of you give a try. So whatever the knowledge you have got based on the previous two questions, with that understanding all of you give a try, and whatever the answer among the given four choices you feel correct, you can mention in the chart. And whoever watching this particular session later, you people can mention whatever the answer you are getting as the correct, you can mention in the comment section before watching the explanation part. Okay. See, actually for solving this question, you don't require pen and paper. That much easy question this is. Okay. And that too, the weightage of this question is 2 marks. You can easily get. Okay. So here, whatever first question we have solved in today's class, based on that concept, you can easily give a try. Okay. So here you can observe in the given circuit. Okay. If you carefully observe, this 10 volt source, 2 ohm resistor and 1 ohm resistor, how these three are connected? How these three elements are connected? Parallel? Yes or no? These three elements are connected in parallel. In parallel, voltage will be same. In parallel, voltage will be same. Okay. Now you can use Ohm's law, that's all. 10 by 2, that is nothing but 5 ampere. Similarly, 10 by 1 is nothing but 10 ampere. Okay. So in this branch 5 ampere current is flowing, in this branch 10 ampere current is flowing together. Okay. Here if you observe, you are having a particular node, right? So in this branch 2 ampere current is entering. In this branch 2 ampere current is entering to this particular node. Okay. And in these two branches together 15 ampere is leaving. Here in these two branches together 15 ampere is leaving. Okay, forget about this direction. Okay, here we have to calculate IS, forget about that. Okay, but just by observing the current, the sum of the resultant current entering and the resultant current leaving, based on that you can guess whether the current direction in this 10 volt source should be upward or it should be downward. All of you give a try. Here 2 ampere is entering, but here 15 ampere is leaving. In which case it is possible? In the 10 volt source, if current enters, then only it will be possible. Say for example, here 15 ampere is leaving, okay, out of which 2 ampere only entering. So that means actually here 13 ampere should, actually here 13 ampere, see this point all are same, right? This point both are same. You can consider as a single. You can directly, you can connect this point to here. Okay. So that means here actually in this direction 13 ampere should come. Yes or no? Here now you can add 13 plus 2, 15 ampere is entering together, 15 ampere is leaving, right? But here in this question, if they have given the current direction upward, then in that case you can consider IS as 13. Okay, so, but you can observe here IS value 13 you are having, but in this question IS direction they have given downward, but actual current direction is upward. That upward current direction is positive. That means downward current direction will be negative. That's all. So IS value is minus 13. The moment you are getting minus 13, okay, minus 13 is there in only one choice. Straight away you can choose. Okay, even though they have asked you to calculate 2 parameters, but the moment with the help of 1 parameter you got the answer. Okay, the moment you calculate 1 parameter, based on that straight away, because that value is there only in one choice, based on that directly, irrespective of calculating the second value, directly you can choose the correct answer. Okay, but for the time being, for understanding purpose, let us try to calculate Vs, whether we are getting the same value or not. Okay, right. So here 2 ampere current is flowing, right? Okay, now in this 5 ohm resistor also same current will flow. Same current will flow by using Ohm's law. 2 into 5, that is 10 volts. Since current enters here, voltage polarity will be plus. Okay, regarding the polarities with respect to voltage for every element we have discussed in the earlier sessions. Okay, whoever watching very first time regarding our network theory foundation course, you people can watch in your free time the earlier sessions which we have taught at our IMS Academy YouTube channel. Just visit the respective playlist regarding network theory foundation course. Okay, right. So here we have to calculate Vs. Okay, just you can apply KVL around this closed path. Otherwise, whatever earlier notations we have followed pattern, same way you can follow. Okay, so here I have to calculate voltage across this particular 2 terminals. I have to calculate voltage across these 2 terminals, right? Now you can observe here you are having 10 volt. Here you are having 10 volt. Okay, I have kept that one as it is. Now whatever this resistor you are having, that resistor if you are keeping vertical alignment, then what will happen, this minus polarity will come down, minus polarity will come down and the positive terminal will come up. Yes sir. See, whatever the terminal resistor here you are having, just keep vertical alignment. When you are keeping vertical alignment, this minus terminal is coming here and positive terminal is coming top. Okay. Now you can observe voltage polarities, once again same, plus minus plus minus. Now we can add, so that means you are getting 20 volts. Okay, so according to this particular circuit, okay, with respect to one side you are having Vs, with respect to other side you are having 20 volt. So that means Vs equal to 20 volts. Vs equal to 20 volts. Okay, I hope it is clear for everyone. Next question, this is a very interesting, all of you give a try. In this particular question, you have to calculate the V1 and then you have to calculate V2. All of you give a try. This is a very interesting question. All of you can mention your answer. Don't hesitate whether your answer is correct or wrong. Okay, no issue at all. For all the questions, I am giving some time. All of you give a try. Whatever the answer you are getting, you can mention in the chart. Okay, so in this question, if you observe, you are having, this is what, dependent source. Okay, output you are getting voltage, sorry, here current direction is there, right? Arrow symbol is there. Whenever you are having arrow symbol, that means it is what? Arrow symbol is there, that is the current source. Okay, you can observe here based on, see, whenever you are having the arrow symbol, that indicates current source. Whenever we are having voltage polarities, whenever we are having voltage polarities, then it is the voltage source. Okay, that is a voltage source. Okay, but in this question, you can observe this current source value is 2I. This current source value is 2I. Okay, that I is nothing but the current flowing through this 4 ohm resistor. Okay, and in this question, the voltage across this current source they have mentioned as V1, that we have to calculate. And similarly, here you are having one current source, it is the independent current source. That's why they have given that value, 5 ampere already given, right? Now across this particular current source also we have to calculate the voltage. Okay, so in this question you are having two current sources, one is independent, other one is dependent. So across each source we have to calculate the voltage. This is a very interesting question. Okay, right. So once again, whatever the questions, if you observe all these questions, okay, either somehow there you are observing one similar pattern. Okay, but in each question I am adding somehow there some typical case I am introducing, so that all the variety of questions you are getting the opportunity, right? So just observe here in this question, we can start from this particular resistor. Okay, because here current value, you know, current flowing through this particular resistor is I. Exact value we don't know, but the current flowing through resistor they have mentioned as I. And you know the 4 ohm resistor. Okay, by using Ohm's law, you are getting voltage across this particular resistor as 4 into I. 4 into I. Now once again you can observe this resistor and this current source all are connected in parallel. In parallel voltage will be same. So that means here V1 is nothing but 4I. Okay, don't get confusion. The difference between 2I and V1. Here 2I, actually this current source value is 2I. Okay, it is the current source, but it is a dependent current source. It depends on other current in this example. But the voltage across that current source is V1. Okay, and here since all these 3 elements are connected in parallel voltage will be same. So the voltage across this particular current source is 4 into I. Okay, now just tell me, without using pen and paper, all of you give a try. Just mention how much current is flowing through 4 ohm resistor. I have already given the hint. Based on that hint, all of you give a try how much current is flowing through 4 ohm resistor. See, it is very simple. In one way, okay, if you want, you can consider, as I mentioned, all these 3 elements are connected in parallel, right? In parallel, voltage will be same. So same voltage you can consider 4I. Now by using Ohm's law, 4I divided by 4, that means I. You can represent like this one way. Another way is, here you are having 4 ohm resistor, here you are having 4 ohm resistor, both are connected in parallel. Okay, and both are having the same resistor value. Okay, so here if you know in one particular resistor how much current is flowing, because both are having the same resistor and since both are connected in parallel, the same amount of current will flow. The reason is, if same amount of current will flow, then only by using Ohm's law, whatever the voltage here you got, you are getting same thing. Otherwise, you are getting different voltage. But in parallel, voltage should be same. In order to maintain the same voltage, since in this particular example, since both are having the same resistors, the moment if you know the current flowing through this resistor, based on that directly you can mention the same current here. Okay, now if you carefully observe, in this resistor the current flowing is I. Okay, in this resistor the current flowing is I. Similarly, in this particular branch, the current flowing is 2I. In this particular branch, the current flowing is 2I. Now you can consider this particular node. Here total 4 branches are connected, right? In these 3 branches together, 4I current is leaving. Whereas in this particular branch, 5 ampere current is entering. Here in this particular branch, 5 ampere current is entering, and here together 4I current is leaving, right? So that means here 4I is nothing but 5. 4I. I hope all of you are getting clarity. Here 4I is nothing but 5 ampere. Since V1 equal to 4I is nothing but 5. That's all. Okay, now just observe all the choices. Regarding V1, you are having 5 volt in only one option. Okay, just like in the earlier question, even though they are asking you to calculate 2 parameters, the moment you are getting one parameter, based on that directly you are able to choose the correct option, because in the 4 choices regarding that particular value, you are having only one option. That is the reason. Okay, suppose if you are having 2 options like that, then definitely with the help of that one parameter, you are able to eliminate 2 choices. Later, with the help of calculation of the second parameter, you can get the correct option accordingly, right? Fine. In this way, even though in the GATE exam, if they are asking you to calculate 2 parameters in the given question, if they are asking as MCQ like this, okay, so with the help of, in some questions, with the help of one parameter, directly you can choose the correct option. But at least from these set of questions, you are getting one more learning also, because nowadays you are having MSQ questions also. Okay, so instead of asking 2 parameters, okay, in the instead of framing the question as MCQ, they can frame similar kind of questions as MSQ. Okay, In 2 choices they can mention regarding V1, in 2 choices they can mention regarding V2. In that case, okay, whichever options are correct with respect to V1, whichever option is correct with respect to V2, accordingly you have to choose. Okay, are you understanding? For MSQ, you have to really carefully check each and every option whether it is really correct or not. Whereas for MCQ, the moment you are getting one of the options, somehow that if you are able to get, okay, directly if it is satisfying, based on that, straight away you can eliminate 3 remaining choices. Okay, that is the difference between MCQ and MSQ. How you have to solve the questions in the GATE exam. The strategy is very, very important. Okay, right. Now, as of now, we got V1. Now, what we have to calculate? V2 we have to calculate. Okay, so here 5 ampere current is coming like this. 5 ampere current is coming like this. Now, by using Ohm's law, 5 into 4, that means 20 volt. You can apply KVL around this closed path, or otherwise whatever the pattern earlier we have told, same thing. Here I have to calculate voltage across these two terminals. Okay, and here if you observe on the other side, just now we got the voltage as 5 volt. Just now we got the voltage as 5 volt. Okay, and here whatever the resistor of 4 ohm is there, just keep this resistor vertical. Okay, if you are keeping vertical element, then you are getting 20 volts. And here also once again voltage polarities are same, plus minus, right? So now we can add the respective voltages. You are getting 25 volts. 25 volts. Okay, so that means here option A is satisfying with respect to V1 and with respect to V2. Okay, in this way, most of the time, especially where you are supposed to write the KVL, of course, if you want, you can write the KVL equation, but whatever that concept is there, KVL, that one you can represent like this. Okay, if voltage polarities are same, then you can add. If voltage polarities are opposite, that time you can subtract. This calculation you can do in the mind level. You don't need to use pen and paper, especially when you are solving the questions based on KVL. That's why I want to cover the GATE questions, whatever the typical GATE questions, interesting GATE questions are there, right? So in order to get good command for all of you regarding this particular concept, I am covering all the variety of questions in this particular session, right? Okay. Now the next question, this is a very interesting question. So up to now we have discussed based on KVL, KCL, etc. Now we are continuing further some more questions, but now I am giving even typical questions. All of you give it a try. Okay. So these network theory questions are something like for your mind or brain, it is a, you are giving some brainstorming questions. Okay, it is a very, very interesting, because even though you might have thought for solving network theory questions you have to use equations and all, of course we may require equations, but the calculation wise you can do without using pen and paper. That means how you are visualizing or how you are seeing the given circuit, based on that is the most interesting thing. Once if you understand or visualize the circuit carefully, from there you are getting a clue from which point you can start solving the question, right? So in most of the cases you can easily solve network theory questions without using pen and paper. Wherever there is a possibility, try to do like that. Wherever definitely pen and paper required, then definitely you can solve in the conventional approach like that. Okay, all of you give it a try. See, regarding power delivered or power absorbed, that concept we already discussed in one of the earlier class. Okay. Now, see, in the basics regarding from the first chapter, when you are solving any network theory question, okay, in some questions they can ask in any particular resistor, in any particular electrical component, they can ask how much current is flowing or how much voltage you are getting across that particular element, etc. And in some questions they can ask how much power is absorbed or how much power is delivered, etc. Okay. Whoever attending very first time regarding network theory subject, if you don't know that regarding the whether the particular source is delivering the power or whether the source is absorbing the power, okay, so you people can visit the earlier sessions regarding the initial. We are having one series, okay, here total we are having 10 lectures are there regarding network theory foundation course. In that first 6 sessions regarding network elements, there I have discussed the first initially classification and then active passive elements and then active elements, right? So in that active elements portion you can refer. So there I have covered that particular concept. Okay, if you refer that concept, definitely you can answer these kind of questions, especially when they're asking power delivered or power absorbed. Of course, based on the requirement you are using KVL or KCL, but ultimately in order to mention the resultant value regarding the power, whether it is positive or negative, to avoid the silly mistakes, that particular lecture is going to help a lot. Okay, so all of you kindly visit our playlist in our YouTube channel regarding network theory subject foundation course and watch the respective lecture in your free time. Okay, right. So for the time being, if you observe in this particular circuit, okay, you are having 1 volt source and you are having 2 ampere current source and you are having 1 volt source. Okay, now the question is what? Power delivered by current source. Power delivered by current source. Okay, here in this entire circuit you are having only one current source, that is 2 ampere. That is 2 ampere, right? So here they are asking what? Power delivered. Delivered means what? Okay, here with respect to source, the voltage polarities you should have like this, because if you are having like this, from positive terminal current leaves, then only this particular source is delivering the power. Okay, right. Now regarding this particular 2 ampere source, we have to calculate the voltage. So for the time being I am labeling as V2A. Okay, somehow that if you are able to calculate voltage across this particular source, then voltage into current is nothing but power. That's all. Okay, now before calculating this voltage, if you observe carefully, here you can consider outer loop like this. Okay, this is one closed path. Yes or no? This is one closed path. Okay, so here -2 plus, that means plus, I am applying KVL around this closed path. -2 plus, +1, then +2 minus, -1, +2 minus, -1. Okay, then here across this 1 ohm resistor, suppose I am mentioning here voltage like this, voltage across 1 ohm like this, right? +2 minus, once again minus, I am considering for every element second polarity. I have applied KVL around this closed path, right? So here +1 -1 will get cancelled. From here you are getting voltage across 1 ohm resistor is 0. Voltage across 1 ohm resistor is 0. Right. So that means here, see, in general we will be considering this particular node as the reference or ground node. Okay. Say for example, if you are considering this is the ground, then with respect to this node voltage will be this voltage V2A. Now tell me, here after doing the calculation, we got voltage across this 1 ohm resistor is 0 volt. That means this is by default 0 since this value is 0. Now once again, here we are getting this value 0, right? So that means here also you are getting 0 volt only. Yes or no? Since here we got 0, right? The voltage across this 1 ohm resistor is 0, and here already this point is connected to ground. So obviously this point will be connected here because there is no drop here. Yes or no? There is no drop here. Now here you can apply nodal equation. Okay, you can apply nodal or KCL. Okay, so just observe here. at this particular point, you are having 1 volt, with respect to what? Ground. You can observe carefully, between these two nodes you are having 1 volt source. That means this node voltage with respect to ground is 1 volt, right? Now here you are having 1 ohm resistor, okay. So here in this particular branch, okay, when you don't know in which direction current is flowing, you can assume that current is leaving, or if you want you can consider entering, no problem at all, okay. Ultimately after doing the calculation, if you are getting the like positive values, that means what is the assumption you have considered, it is correct. Otherwise you can change the direction, no problem, okay. Similarly in this particular 1 ohm resistor, at this particular terminal you are having V2A, and here at this node you are having 0 volt, okay. So here in this case current will flow like this, okay, right. And in this particular branch you are having already current value given. Now you can apply KCL at this particular point, KCL or nodal equation, no problem. So here you can consider in this particular branch, V2A is one side voltage, other side voltage is 1 volt. The voltage difference across these two terminals is nothing but voltage across this particular 1 ohm resistor, and divide by 1 ohm resistor. By using Ohm's law, you are getting the voltage. Okay. Voltage divided by resistance is nothing but current. Okay. Similarly, in this particular branch, current is entering. So entering current is negative. And in this particular branch, the current leaves. Leaving current is positive. Leaving current positive, entering current is negative. If you want, you can consider exactly opposite also, no issue. Ultimately, you will be getting the same answer, right? So in this particular branch, you are having, since this voltage is 0, that means across this 1 ohm resistor, you are having V2A. The voltage is V2A. Divided by, once again, resistor value is same, 1. Okay, we have just applied the KCL. KCL means very simple. If the, like, for a particular node, like whatever the number of branches you have connected, right? So sum of all the leaving currents equal to 0, or sum of entering currents equal to 0, or sum of leaving currents equal to sum of entering currents, like that, okay. Otherwise, you can consider if entering current is negative, leaving current is positive, like that, whatever the branch currents are there, so you can write in one equation like this, right? Now just do the simplification. Here in this case, V2A plus V2A, that means 2 times V2A, then minus 1 minus 2, that is minus 3, is equal to 0. From here you are getting 2 times V2A is equal to 3, okay. From here we are getting V2A is equal to 3 by 2, that means 1.5 volt, okay. 1.5 volts you are getting. 1.5 volts you are getting, right? Otherwise, if you want, you can keep like 3 by 2, no issue at all, okay. Now in this question, we got 1.5 volts, yes, whatever the notation we have considered, exactly it is matching, because here you got positive value and here positive terminal, negative terminal, the polarities wise it is matching, right? Now since whatever the notation we have considered as per the given question, it is satisfying, okay. Suppose if you got the negative, then accordingly we have to change the polarity, right? Fine. Now in this question, we got the voltage, we got the current. Now we have to calculate the power delivered by this current source, right? So power delivered by current source. Power delivered by current source is voltage into current. Voltage into current, okay. So in this question, voltage just now we got 1.5 volt and current value is 2 ampere. Current value is 2 ampere. So 2 into 1.5, that is 3 watt. Suppose here you have represented 3 by 2, then 2 will get cancelled, then directly you are getting 3. No problem. Even if you are doing simplification or if you are keeping same, final answer will remain same. Okay, based on your convenience, accordingly you can do the calculation. I hope all of you are getting the clarity. So initially I have applied KVL for external closed path, and then I have applied the KCL at this particular node. With the help of these two, we got the voltage across this particular current source, and then since they have asked to calculate power delivered by the source, so power delivered by source is 3 watt, like that, okay. Right. Now with this understanding, all of you give a try for this question. All of you give a try. So this question also you have to observe carefully from the given circuit. If you are observing the circuit, from there you will get the clue. For all the network theory questions, whenever you are having like, okay, you have to observe the circuit. If you are observing the circuit, then only you are getting the clue from where we can start. Okay, all of you give a try. Whoever watching this party session later, so you people can mention your answer in the comment section. Yeah, just observe carefully. In this question also, we are asking power supplied or power delivered, both are same, by the voltage source. Okay, in this particular question, you are having voltage source and two current sources, right? So with respect to this source, they are asking how much power delivered, how much power delivered, right? In the previous question, they have asked with respect to current source. That time we know the current, we have calculated the voltage. Okay, and then we have done the product. Similarly, here we know the voltage, somehow there. Okay, now you can observe. Now you can observe here the polarities. Here from positive terminal the current is leaving, right? So that means same. Here from the positive terminal current leaves. Suppose I am assuming that current flowing through this 10 volt source, okay, in this direction is I. If you are able to calculate I, after that we can multiply, that's all. Okay. Now if you observe at this particular node, in these two branches together 3 ampere current is entering, 1 plus 2, 3 ampere. That means resultant current 3 ampere should leave like this. Okay, so that means here to this particular node, in these two branches, I plus 3 current is entering. That means here I plus 3 current will leave. Okay, similarly here at this particular node, if you apply KCL, okay, I plus 3 current is coming here, out of which 1 ampere is leaving. That means in this branch I plus 2 current should leave. See, you can cross check. If you are adding these two, 2 plus 1 is what? 3 plus I plus 3. Say this current is coming, the resultant current is leaving, right? Same current. Now once again, if you apply KCL at this particular node, here I plus 2 current is coming, okay, out of which 2 ampere is going here and I current is going like this. That means whatever the entering current is there, together it is leaving. Yes, it is satisfying. In that way you can cross check from where you have started. If you are able to get the same current, that means whatever the KCL you have applied at the intermediate nodes, all are correct only. Suppose if you are getting different, then you can cross check somewhere you have done the mistake. Okay, right. Now just observe, these two resistors are connected in series. In series we can add the resistors, 1 plus 1, that means 2 ohm. And similarly these two resistors are connected in series. In series we can add the resistors. Now what is our objective? We have to calculate the I. Okay, just like in this question we have applied the KVL around the outer loop. Okay, in the same way here we can apply the KVL around the outer loop. Okay, so here current is entering like this. That means voltage polarities you will be getting plus minus. Similarly current enters here, voltage polarities plus minus. Just you have to apply KVL around the outer loop. KVL you have to apply around the outer path. Like this you have to apply. Okay, so minus 2 plus, that is plus 10, then plus 2 minus, here current I plus 3 is flowing, the resistance value is 2. Okay, similarly in this branch I plus 2 current is flowing, once again resistor value is 2, is equal 0. Only 3 elements are there, 10 volt, here 2 ohm and here 2 ohm. Okay, that's all. Now here 10 minus 2 into I minus 6 minus 2 into I minus 4 is equal 0. Right. So here minus 6 minus 4, that means minus 10 plus 10 minus 10, that means you are getting 0, is equal to 2I plus 2I, that is 4I. From here you are getting I equal to 0 ampere. Right. So in this question they are asking power delivered by 10 volt source. So power delivered by 10 volt source is voltage into current. Here voltage is 10, current value we are getting 0. That means you are getting 0 watt. 0 watt. So that means this particular source is not delivering the power. Okay. So earlier in one of the session we have covered even variety of questions, right, where the source is delivering the power, in which cases like when you're having multiple sources present in the given circuit, that time it's not compulsory that each and every source has to deliver the power, right? Based on the network elements that are connected, based on that few sources can deliver the power, few sources can absorb the power, and few sources they neither deliver the power nor absorb the power. That means whenever you are getting like 0 watt. Okay, suppose for the same question if they are asking instead of power delivered, if they are asking power absorbed, same answer, because plus 0 and minus 0 we are considering as 0 only, like that. Okay, I hope all of you are getting good command with respect to KVL, KCL, and even power delivered, power absorbed, etc. Okay, right. So with this understanding, now let us proceed to the next very simple topic, equivalent circuits with respect to active elements. In earlier session when we have discussed the passive elements, there we have discussed the equivalent circuits with respect to passive elements like series connection, parallel connection, etc. Similarly, series connection, parallel connection, now let us see with respect to voltage sources and with respect to current sources. Okay. Yeah, say for example, here I am connecting two voltage sources. V1 and V2. Okay. Similarly, all of you give a try what you are going to get the equivalent circuit. If I want to represent as a single voltage source, what will be the this voltage source value? All of you give a try. Okay. Similarly, here I am considering two current sources like this. Okay, whatever this circuit is there, if you want to represent equivalent circuit as a single source, in that case what could be the this current source value? All of you give a try. See here how these two are connected, series. Here voltage sources are connected in series, and here in this case polarities are same. You can apply KVL, or otherwise whatever earlier notations we have discussed while you are applying KVL, same logic you can apply. Here you are having plus minus, here also plus minus, that means polarities are same, we can add. So directly you can represent V1 plus V2. If suppose polarities are opposite, then you have to subtract those two voltages, okay, one voltage from other voltage. But whenever you are getting voltage polarities are same, then you can add. That means whenever voltage sources are connected in series, if they are having the same polarities, then you can add the respective voltages, that's all. Okay. Similarly, here you can apply KCL at this particular node. If you apply KCL at this particular node, here I1 is current, I1 current is coming, here I2 current is coming. So together I1 plus I2 should leave. I1 plus I2 should leave. That means if you want to represent this entire circuit as single circuit, you can represent as I1 plus I2. So that this current is flowing in this particular branch. This branch and this branch both are same, right? Like that. So in this way, whenever current sources are connected in parallel, that time if the current directions are same, then we can add. Suppose current directions are opposite, then we have to subtract, like that. Okay, I hope all of you got the clarity. Now with this understanding, I am going to represent in other way, exactly opposite way. Okay, now all of you give a try. So voltage sources I am representing parallel. Here this is V1, this is V2. if you want to represent as a single voltage source, now in this case what will be this value? All of you give it, right? This is the most interesting. All of you give it, right? Here I have connected voltage sources in parallel. Okay. Similarly here I am considering current sources in series. Now in this case, what will be the equivalent circuit value? The current source value will be how much? Here I have connected the current sources in series. All of you give it, right? This is the most interesting one. Generally here students will do silly mistake. Okay. Here they may say that this voltage source value is V1 plus V2. But that is wrong. Why? See, earlier if you have connected batteries like this, say for example in the TV remote or AC remote, you are using suppose 2 batteries. That means how those two are connected? Series? Yes or no? In series, if you are having same polarities, that means together resultant voltage you are getting V1 plus V2. Okay. But if you are connecting in parallel, we have solved earlier also so many questions in this particular session, even in the earlier sessions. In parallel, which quantity should be same? In parallel, voltage should be same. That means here V1, V2 both should be same value. It's not that both are like different. Okay. So here V1, V2 both are same. If this is 5 volt, this will be 5 volt. Or if this is 3 volt, this should be 3 volt, like that. You cannot connect 5 volt battery with 9 volt battery or something like that. Two different batteries you should not connect parallel, because in parallel voltage should be same. Okay, right. Similarly here, sometimes few people may say that the resultant current is I1 plus I2. That is wrong. The reason is, see, I1 plus I2 where you are getting? When the current sources are connected in parallel, if the direction is same, then accordingly you are getting I1 plus I2. But here I1, I2 are the two current sources. But how these two are connected? In series. In series, current should be same. That means here also I1, I2 not like different current sources, both are like same. That means in simple logic, whenever multiple voltage sources are connected, okay, since ultimately you are getting single voltage source, that value should be same. That's why, like with respect to this source, the second one is like redundant, or with respect to this one, first one is like redundant. That means no need to connect multiple voltage sources in parallel. You can connect one voltage source, that's all. Similarly, if you want to use multiple current sources, okay, in the series, that is not really required. One current source will be sufficient. Okay, you can replace the whatever the given circuit is there, you can represent simplified circuit like this. Okay, I hope all of you are getting the clarity. In series, current should be same. In parallel, voltage should be same. Okay, right. So this is with respect to equivalent circuits, with respect to voltage sources and current sources, with respect to parallel configuration and series configuration, how to reduce or how to simplify the given circuit. Okay, I hope all of you got the clarity. So in this particular session, overall we have discussed with respect to KVL, we have discussed variety of gate questions, and after that we have discussed so many interesting questions and typical questions based on KVL, KCL and Ohm's law, and even interesting questions with respect to KVL. Generally people may think that KVL we can apply only when you are having a big circuit or any simple circuit which is having like two meshes, say for example, we can apply like that. But even we can apply KVL for outer loop also, outer closed path. Okay, so wherever some interesting questions are there based on both KCL and KVL, even those questions we have covered, and in fact we have covered some questions based on power delivered also. Okay, I hope all of you got the clarity. So whatever total 10 sessions are there regarding network theory foundation course in our YouTube channel at our IMS Academy. So whoever not yet watched earlier sessions or some of the sessions if you have missed, no issue at all. So in your free time, just visit our YouTube channel, IMS Academy YouTube channel, and go to the playlist regarding network theory foundation course and just watch all those lectures whichever you have missed earlier, right? So total 10 sessions are there. In those 10 sessions, 6 sessions I have dedicated for the network elements, like with respect to classification and with respect to passive elements and then with respect to active elements, and we have discussed in detail regarding the basic laws, everything, whatever the basic concepts are there with respect to first chapter I have covered in detail. Okay, and then whatever the 4 sessions are there, in those recent 4 sessions I have, including this session, the previous 3 sessions, together 4 sessions I have focused on basic laws like KCL, KVL, etc. Right. So with these 10 sessions you are getting good command. Okay, even though this is a foundation course, okay, I have covered the concept, I have discussed variety of gate questions and practice questions as well, so that with the help of, if you know KCL and KVL, how easily we can solve the gate question regarding network theory subject. With this understanding, when you are studying the advanced like upcoming chapters of network theory subject, even analog circuit subject, etc., later in your free time, for solving those questions, definitely these basics will help you a lot, because generally most of the students will face the problem regarding network theory subject, how to write the voltage polarities, or how to consider current direction, or how to apply KCL or how to apply KVL. If you are not strong on the basics, okay, how to consider passive sign convention or like voltage polarities, plus minus, right, or direction of the current, if you are not confident regarding that notations, then definitely whatever the concepts you might be learning in the network theory subject or even analog circuit subject, definitely you may be doing more number of silly mistakes. If you want to avoid all such kind of silly mistakes, then you must and should watch the entire foundation course together regarding network theory subject. Together we are having 10 sessions, right? All those 10 sessions, more or less, each and every session we are having around 1 hour, right? So all of you kindly watch, and not only that, all of you kindly share this playlist also with all of your friends, so that they also will get benefited from this network theory foundation course, right? So before ending the session, whatever the 2 updates I have given at the beginning, once again I am discussing. Okay, so whoever not yet joined till now, all of you kindly join our Telegram channel regarding this particular link already provided in the description. Okay, and one more important update regarding live online program which we are offering at our IMS Gate Academy. So whoever interested for enrolling for Gate 25 26 at our IMS Gate Academy for live online program, so all of you can contact to any of these 2 numbers. Our counselors will discuss in detail about our live online program, and even if you are having any doubts, okay, regarding our live online program, you can ask all your queries to our counselors. They will clarify all of your doubts, and after that you can enroll, so that you can get the maximum benefit by enrolling for live online program at our IMS Gate Academy. If you are aspiring to get very good rank, then don't miss this golden opportunity, right? Okay. Yeah, with this we have covered regarding network theory foundation course. So we'll meet you all in the next series in the upcoming sessions. Okay, thank you everyone.